Here we have topic 3.4, integration by parts, question 3a, the integral of e to the power of p cos of p dp. This is a special case here. These are tough integrals, so you're going to want to work through this one slowly, piece by piece, understand each step as we go. Now, we need to pick a u and a v, but there's going to be a problem here. I've always said before that first of all, I need to be able to integrate whatever I choose for dv. Yeah, I can integrate e's and I can integrate cos's, that's fine. But whatever I pick for u, say I had a 3x squared, I know that if I keep differentiating it, it eventually comes down to 0. And that's usually my ideal candidate for a u. But however, we'll see neither of these will actually differentiate down to 0 at all. So let's just get cracking on this. We'll just pick u equals e to the power of p and dv equals cosine of p, and we'll see how this works out. Same steps. So du dp in this case, the derivative of e to the power of p is e to the power of p, and the integral of dv, or the integral of cos, is sine of p. So v is equal to sine of p. So what we're going to do is we're going to apply our formula. The integral of u dv equals uv minus the integral of v du. Okay, the integral of u dv is what they gave us, e to the power of p cos p. Now let's set up the solution to that. It's u times v. So that's e to the power of p sine p minus the integral of v du, which is sine p by, du equals e to the power of p dp here, apologies. So it is sine p by e to the power of p dp. So e to the power of p sine p dp. Okay, and you notice what happens here is we're back to a situation where I'm going to have two things that are going to be, integration by parts is going to be difficult there, because again I'm going to have an issue where whatever I derive will not eventually derive down to 0. But look, let's keep going and see what we have. Okay, so the e to the power of p sine p minus. So inside in here, let's try our integration by parts again. So let u equals e to the power of p, and let's dv equals sine of p. Right, du dp equals e to the power of p. Du equals e to the power of p dp. Now the integral of dv of sine is minus cosine of p. So v is minus cosine of p. So again, we'll use our integration by parts formula to solve that integral. So I've got to do u times v. So minus e to the power of p cos of p. Alright. Then I've got minus v times du, minus the integral of v times du. So minus the integral of v, which is minus cos of p by du dp by e to the power of p dp. So that's minus e to the power of p cos p dp. Okay, I'm going to pause this there for a second. So just remembering on the left hand side here, what I'm integrating from the start is e to the power of p cos of p. So I've got the integral of e to the power of p cos of p is equal to all of this, and let's sort out our signs. And here's where things start to fall into place for us. So minus minus is a positive, so e to the power of p cos of p. Then I got my minus minus is a positive there, the integral of minus e to the power of p cos of p dp. And last time, tidying up before we start moving things around, I'm just going to sort out that final remaining minus. So e to the power of p sine p plus e to the power of p cos of p, and I'm going to bring this minus outside, minus the integral of e to the power of p cos of p dp. Okay, and here is the thing. We've got an equation here. The integral of e to the power of p cos p is equal to all of this minus e to the power of p cos dp. Those two things highlighted in pink are the same. So this guy is a minus, so let's bring him over here to the left hand side. I'd have my original e to the power of p cos p, and when my minus 1 comes over, he becomes plus the integral of e to the power of p cos p. And that's equal to e to the power of p sine p plus e to the power of p cos p. Now, I have two things that are exactly the same. I have two of them, one here and one here. So altogether I have 2 times e to the power of p cos of p. Just to be clear, if I have x and I have x, that means I have 2x. That's what I'm doing, just adding them. So equals to e to the power of p sine p plus e to the power of p cos of p. Now let's be very, very clear. This is the thing that I've been asked to differentiate at the very beginning. The only thing that's different about it now is I have a 2 in front of it that's multiplying. So when that 2 comes over, it will divide. So the integral of e to the power of p cos of p equals everything on the right divided by 2. E to the power of p sine of p plus e to the power of p cos of p all over 2. And then don't forget at the end to add your plus c. If you wish, you can of course present the answer. If the whole thing is divided by 2, you can just say each individual one is divided by 2. It's the same thing.